Good morning, students. Moving back to chapter 4, that is chemical kinetics. Let me recap whatever we have seen till now. We have seen what is the definition for chemical kinetics. Then we saw what is a rate equation. We saw what is a rate constant. Then we saw what is the order of reaction. What is the order of reaction, children? Order of reaction is defined as the sum of the powers which is raised to the concentration terms. Okay. And we as per the order we saw what is first order reaction, second order reaction, zero order reaction, and what is pseudo order reaction. Pseudo order reactions are nothing but reactions which proceed with the higher kinetics, but actually they appear to be in higher kinetics, but actually they are in the lower rate kinetics. Then we saw what is the relationship between reaction rate and temperature. For that we saw about Arrhenius equation. So when temperature increases, the reaction rate also increases. When temperature increases 10%, then the reaction rate is doubled. We saw that reaction. Then we saw what is half rate of a reaction. What is meant by half life of a reaction? It is nothing but time taken for the reactants to reduce into half from its initial concentration. So we saw that too. And while we were dealing with Arrhenius theory, we saw what is activation energy. It is the energy required to form an unstable complex. The unstable complex lasts only for very less time period. Then it breaks down to give you products. So energy required to form that complex, to form that activated complex, is called as activation energy. So I told you the statement, when temperature increases, reaction rate increases. With 10 degrees centigrade rise in temperature, then the reaction rate is doubled. How come that occurs? See, this is a graph which is going to plot the fraction of molecules along with the kinetic energy of the molecules. Now, this is the most probable kinetic energy. My intention is, when temperature increases, then the kinetic energy possessed by the molecule increases. As a result, the reaction rate is doubled. Okay. Now, see, when you look into the peak of the curve represents the kinetic energy. That is going to represent the most probable kinetic energy. That is the kinetic energy of maximum fraction of molecules. When temperature increases, the curve is moving to the higher energy value, and as a result the curve broadens out. That is, it spreads towards right, means large amount of molecules are having a kinetic energy. So this is the reason for increase in reaction rate for every 10 degrees centigrade rise in the temperature. See, this is nothing but your Maxwell-Boltzmann distribution curve. This is one of the limitation. In order to overcome the limitation of Arrhenius theory, since Arrhenius theory is not included for exam, I am not going to highlight much about your Maxwell-Boltzmann distribution theory. Let me just give you an outline telling we are plotting a graph of fraction of molecules against kinetic energy. The area under the graph is representing the number of molecules. The number of molecules under T2 and T1 remains the same, and this shaded area is representing the number of particles which has exceeded the activation energy. Okay, they have exceeded the activation energy. Now this is a graph of fraction of molecules having certain kinetic energy, and this is the kinetic energy. See, when you reach the peak, when you see the peak of the curve represents the maximum number of molecules having most probable kinetic energy. So when temperature T2 is greater than T1, what happens to the number of molecules possessing kinetic energy? Moving to the last topic, that is effect of catalyst in the reaction rate. We might have seen about the effect of catalyst from lower classes. That is, whenever there is a presence of catalyst, then reaction rate increases. Your catalyst is going to form a temporary bond with the reactants. It forms an unstable intermediate complex which decomposes or which breaks down to give you product. This is exactly same as that of your activation energy, that is your Arrhenius concept. That is, when temperature increases, reactants colloid to form an intermediate complex which lasts only for short period of time, that breaks to give you product. Similarly, whenever a catalyst is present, the catalyst forms a temporary bond with the reactants, As a result, a complex is formed which lasts for a short period of time. It breaks down to give you the product. So this is the effect of catalyst. And catalyst changes the rate of chemical reaction without the catalyst being undergoing chemical change. Means the catalyst will not undergo any permanent chemical change provided it changes the rate of the reaction. For example, you consider the reaction where MnO2 is catalyzing this particular reaction. So when Mn2 is present, what happens to the reaction rate? See, the catalyst is participating in chemical reaction. It forms an intermediate complex which is only for temporary existence. It decomposes to give you product. As a result, your catalyst will be regenerated at the end of the reaction. And this is about the intermediate complex theory. Intermediate complex theory is a theory which is going to explain the effect of catalyst on the rate of reaction. Say for example, whenever a catalyst is present, the catalyst will be providing an alternate reaction mechanism, or it is going to provide an alternate pathway so that activation energy is reduced between the reactant and the product. As a result, a barrier is lowered, the potential barrier is lowered, so the rate of the reaction is increases. So what is intermediate complex theory? Intermediate complex theory suggests that in the presence of catalyst, the activation energy between your reactants and the products decreases. As a result, the potential barrier is lowered, so the reaction proceeds fast. Okay, only two aspects in intermediate complex theory. Whenever there is a catalyst, what it will do? It reduces the activation energy of reactant and the product. When activation energy is less, then potential barrier is also lowered, so the reaction proceeds fast. Now, see, this is a curve where we have plotted free energy and the progress of reaction. When you look into the energy of reactants, the energy of reactants increases. The progress of the reaction is increasing. It attains a peak. Finally, it has given out the product. So, this is the reactant and this is the product. This is the progress of the reaction. Now, without enzyme, you look into the activation energy. Your activation energy is more without the presence of enzyme catalyst. Say for example, when I supply the enzyme catalyst, the activation energy is less. If activation energy is reduced, then change in free energy. When activation energy is less, the barrier is removed, so reaction proceeds very faster. Now, what are the features of catalyst? What are the features of catalysis? In that, see, a catalyst will not initiate a reaction. It has no role in initiating reaction. When a reaction is going to proceed, right, what it will do? It catalyzes a spontaneous reaction which is underway. And catalyst will not change the equilibrium constant, but it helps to attain the equilibrium faster. It won't do any role in changing the equilibrium constant, but what it will do, it helps the reactants to reach the equilibrium faster. It catalyzes the forward reaction and the backward reaction in the same extent. Like it gives equal importance to forward reaction and the backward reaction, but means the equilibrium state remains constant provided it is reached a little bit earlier. So what are the features of catalyst, children? See, when a catalyst is present, it is not going to do any role in changing the equilibrium constant of a reaction, but what it will do, it will help the reaction to reach the equilibrium faster. Okay, this is one point. Second point, it catalyzes the forward reaction and the backward reaction in the same extent. But what is that? The equilibrium state will be constant, but equilibrium will be attained a little earlier. Okay, so these are the features of catalyst in catalyzing a rate of a chemical reaction. Now, collision theory is not there for final exam. So I am just giving you an outline about the collision theory. Collision theory was proposed by Trotz and Lewis in 1916 to 18. What does this theory assumes? This theory assumes your reactant molecule as hard sphere. So as per collision theory, your reactant molecules are behaving like a very hard sphere. What are the postulates of the theory? See, there are 4 postulates. A reaction takes place when reactant molecules collide with each other. Yes, we all know. When reactants collide, then only we'll be getting a complex, then we'll get a product. So when reactants collide only, the reaction proceeds, correct. Then The collision which brings about the chemical reaction is called as effective collision. Not all collision brings about the product. Some collision will give rise to an intermediate complex. We need to break that intermediate complex to give you the product. So not all the collisions are bringing out chemical reaction. The collision which brings about chemical reactions, we are going to call them as effective collisions. And what is threshold energy? The minimum energy which the colloiding molecule should possess to make the collision effective is called as threshold energy. The colloiding molecule, that is the reacting molecule, should possess a minimum amount of energy so that the collision will be effective. That energy is called as threshold energy. And what is threshold energy? It is nothing but activation energy plus energy possessed by the reactant molecules. We already know about the activation energy. And the number of collisions per second per volume of the reaction mixture is called as collision frequency. What is collision frequency? The number of collision per second per volume of the reaction mixture is called as collision frequency. While doing the recap, children, I forgot to explain about the molecularity and elementarity of the reaction. Hope you remember about the molecularity of the reaction. The number of molecules or ions or atoms which colloid to give you the product is called as molecularity. And as per the molecularity, we have classified the reaction as like molecularity 1, molecularity 2. And what is elementary reaction? Elementary reaction proceeds in a single step. It won't proceed with multiple steps. The reactions which proceed in a single step is called as elementary reaction. So in the entire chapter, your Arrhenius theory is not there for exam and collision theory is not there, and Maxwell-Boltzmann theory, which is coming under Arrhenius application, is also not there. So but we have seen the little bit of outline under that. Thank you, children.